Hello and welcome. In this video, we're going to be learning how to calculate the tension in the string when we have a problem like this. Before we proceed, feel free to pause the video and give it a trial. Now, the question says, if mu, this is coefficient of friction, if the coefficient of friction is given as 0.5, find the normal reaction on X, which is this box right here, and the tension in the string. Alright, so now looking at this, we have a box of 5 kilogram and we have another box, we have a box X of 5 kilogram and we have another box Y of 7.5 kilogram. This means that motion will tend to go in this direction because we have more weight in this direction. Alright, so the direction of motion, or let's say the string, will be pulled down because 7.5 kilogram is more than 5.0 kilogram. And so the question says find the normal reaction on X. So here we have block X. Block X has a mass of 5 kilogram and block X resting on this surface will act downwards with a weight of mg, which is 5 times, let's take acceleration due to gravity as 10, so the weight will be 5 times 10, which is 50 Newton. And whenever we have a weight acting downward and a body resting on the plane, it will have a normal reaction which will act directly opposite and equal to the weight. So the normal reaction will simply be the weight, which is mg, the mass times the acceleration due to gravity, which is 50 Newton. Okay, now to calculate the tension in the string, we know that this body is being pulled downwards or is being pulled in this direction, and so the tension will be greater than the force in this direction. Now let me explain something. When this body is being pulled in this direction, the frictional force comes in to limit the movement of this block. The frictional force comes in to limit the tension in the string, to oppose the motion of the tension in the string. That's why we have the frictional force here in this direction. Okay, and so the tension in the string will be more. Because the tension in the string will be greater, that's why the object is able to move in this direction. The tension in the string will be greater than the frictional force, because here we have 7.5 kilogram pulling down 5.0 kilogram. And so our net force from Newton's law of motion, we know that our net force is mass times acceleration. And so our net force will now be the tension minus the frictional force. The tension in the string minus the force, because the tension will be more than the frictional force, and that will be equal to ma. And so tension minus mu r, frictional force, which is coefficient of friction multiplied by normal reaction, is equal to ma. And so we're going to use this formula. Let's call this equation 1. Now when we come here to this side of the diagram, we have that the tension, the body is coming down, or the string is coming down in this direction, and the weight will act downwards. The weight of block Y will act downwards. But there's going to be an opposition to the weight of block Y to limit the movement of block Y, and that is going to be the tension in the string. The tension in the string will act upwards as the weight acts downwards. And so because the body is moving downwards, the weight will be more than the tension in the string. The acceleration is in this direction, and so the weight of this block has to be more than the tension, or else it would not move down, it will not move downwards. And so because of that, still following this formula, that net force is mass times acceleration, we have to say that mg minus t is equal to mass times acceleration, because the weight of the body is more than the tension. And so we have our equation 2 mg minus t. So what we simply do is to substitute. And so from equation 1 we have that t minus mu is 0.5, r is 50 Newton, 50 equals to m is 5 kilogram, because here we're dealing with block X for equation 1. So we have 5 kilogram multiplied by acceleration a. So t minus 0.5 times 50 is 25 equals to 5a. So let's call this equation 3. And then here mg, m is 7.5, dealing with block Y. 7.5 multiplied by g is 10 minus t equals to m 7.5 times a, ma. Alright, so 7.5 minus 10, 7.5 times 10 is 75 minus t equals to 7.5a. And so we can rewrite this in this format so it's easy for us to solve. So bringing t to the front, or bringing t first, we can have it as minus t plus 75. Same thing, 75 minus t is same as minus t plus 75 equals to 7.5a. So we have equation 4. This equation and this equation, they have the same format, so we can solve them simultaneously. So let me clear out this part. So we have t minus 25 equals to 5a, and we have minus t plus 75 equals to 7.5a. So using elimination method, you can add this to eliminate t. You can add equation 1 and equation 2. And so t plus minus t gives us 0. Minus 25 plus 75 gives us 50. And that is equal to minus 5a plus 7.5. That should give us 12.5a. And so when you divide both sides by 12.5, you have a to be equal to 50 divided by 12.5, and when you type this in your calculator, you get 4 meter per second squared. And so having our acceleration, we can easily calculate our tension from this equation. So we can say from t minus 25 equals 5a, t equals to 5 times 4, which is a, plus 25. And we can calculate this and get our final answer as 20. 5 times 4, 20 plus 25 to get 45 Newton as our tension. And that is it for this video and this question. Don't forget to like, share, subscribe, leave your questions in the comments if you have any questions. Thank you for watching, and goodbye.